Hello, everyone. This is Rich Kick from Newbury Park High School in California, and my colleague is
Gina McCarley, and I'm in North Alabama.
And today we are going to be talking about preparing for the Advanced Placement Computer Science exams. I will be discussing the Advanced Placement Computer Science A exam.
And I'll share about the Computer Science Principles exam.
So at this time, I'm going to share some slides. And at this point, I'm still looking at the share button. Gina, do you know where the screen sharing is? Or if Peter could jump in here and say what option you actually use to share the slides.
Okay, I'm looking at the poll, Rich. The majority of the people are here for CSA. We have 75% here for CSA and 25% for CSP.
Excellent, thank you very much. And again, I'm still looking for the option to actually share the slides. Screen share, got it. And I will just go with the Chrome tab and we should be set. So Gina, are you able to see those slides?
Yes, I can see them on the side.
Okay,
yes.
And they're relatively small, so at this point, I guess we're going to probably make that full screen and allow them to see the slides and not necessarily see us.
Right.
Okay. And we still see our icons in the bottom corner. And so at this point, we would like to first of all thank all of you for joining us for this session. We are going to be discussing the Advanced Placement Computer Science A exam first, and then Gina will talk about the AP Computer Science Principles exam, and then we'll have time for questions. So I am going to slide through the presentation, emphasizing that there were 3 different ways to actually connect here. You could use your Twitter account or an Instagram or a, looks like a Google account. Here are some of the norms we would like you to adhere to. Make sure that when you're chatting with each other, you're nice. You're gonna look forward to meeting other people and you're gonna ask quick clarifying questions. If you ask questions in the parking lot, post any questions you have. Upvote when other questions that you want have been answered, and then comment on questions that you can help with. And then be helpful. Make sure you answer other people's questions, post good resources, and share tips and tricks.
If you would, Rich, the down arrow beside the word present, if you would go ahead and click it and choose presenter view, it'll fill the screen.
Okay.
Up on your Google Slides. Can you do that? Does it give you that option?
What I was told during the training is if we do that, we might not be able to view, but let me try and you tell me how it goes. Let's
okay.
try.
Don't do the present. Yeah.
Are you okay?
Yeah, I'm okay. I think it's going to fill the screen so we can see.
That sounds
yeah, that's much better.
Give me the feedback if we need to adjust in any way. So
yeah,
I'm going to start with a short presentation of the Advanced Placement Computer Science A exam. And if you're not aware, this is the sample question that was recently released by the College Board. So we know for this new exam circumstance, these are going to probably be the best practice questions your students can do in this last minute preparation for the exam. So what I want to emphasize very quickly is when your students see an exam question, they could start reading this text. But what I recommend is they jump straight to the concept models, otherwise known as the classes that are going to be given in these problems. So in particular, when they start reading this question, if their glance would jump immediately to the class that's given and notice the name of the class, and in particular, look at the 3 things that actually make up a class: the fields, the constructors, and the methods. And in this particular case, students should immediately recognize that there are no instance fields or instance variables given, and there are no constructors mentioned. So what will help students very quickly is they can recognize that there is nothing here that they have to write. It's simply something they have to recognize as a concept or a class that will be used to answer the other code that they're going to be given. So in this particular case, you can see the name of the class is Gizmo, and without reading anything else, you can see that a Gizmo can get maker, which will be a string. The Gizmo can determine if it is electronic, which will be Boolean true or false. And the Gizmo also has a method that requires a parameter. If you send it a reference to an object, in this particular case, a Gizmo object reference, it will return whether that reference, that the object that the reference refers to is equal to or equivalent to the object that is represented by this class. So if the students jump to the class and recognize that the concept of Gizmo is something they need, and getMaker is electronic and equals will be the methods they will be using, then when they read to the next slide, it will probably make more sense to them. Again, they could read these words, but if they're looking to maximize their time, they should again immediately jump to the next set of code and recognize that the new class that they're given does have an instance field or an instance variable and does have methods that are labeled Part A and Part B. So make sure you encourage students to immediately look for those Part A and Part B labels, because that's what they're going to be writing. And now we understand why the Gizmo class was given. The online purchase manager, which will be the code that the student actually writes, requires that they use an instance variable, purchases, which has a array list of Gizmo references. And then they're going to need to know that if you send count electronics by maker, the name of the maker, it will return a count. And then they will also know that if it has adjacent equal pairs, by having no parameter, that usually means you're going to use the instance field instead of looking for a parameter. Determine if any two adjacent pairs are equal, and then return true or false. So my suggestion for the AP students getting ready for this test is go back. You can look at the question text, but look at the code, determine the concepts associated with the particular problem, look at the next group of code and immediately identify which parts they're going to be writing, and try to understand how the previous code integrates with the current code so that they can answer those questions more effectively. Now we're going to move to Gina's summary.
Okay, according to the poll that I asked you to fill out, 100% of you that responded have not completed the Create. You have completed the Explorer. I've just added a few tips about Create that I'm going to share, and then you can ask specific questions in a little bit if you have more specific questions about that. For Create, you have to actually make a video of your code running. And one of the keys on this is the video should be created by you independently. It's not collaborative. It should demonstrate your code running. So if you made a game, you should be able to see the game being played. And it should not be any kind of screen shots or slides, any still pictures. This is evidence that your code actually runs error-free. For the written response, there was tips on the previous page. For the written response, you need to make sure that you address all the prompts and you use the words of the requirements in your response. If they ask the programming language you use, don't think of some fluffy words for programming language. Say, the programming language I used was Java, Python, Snap, whatever it is. Address the prompts. Okay. For coding tips, you're asked to capture your entire code. Make sure that you capture your code in the language that you coded it. Some students use, for example, code.org App Lab. And in App Lab, you have an option to swap to the JavaScript, but a lot of the students actually code it in the blocks. And it gets real confusing when you read the written response of somebody that actually drug the blocks onto the screen and they turn in their JavaScript text code. Sometimes their description doesn't match up very good. Make sure that you mark an oval, the algorithm that you create, and mark a rectangle around the abstraction that you developed. It can't be an abstraction that's built into the coding language. It has to be something that you developed. This shows the reader when they're grading it that this is the abstraction or algorithm that you want to talk about, and it helps to show understanding. If you had somebody to collaborate with you, make sure that you put in the comments any code that you didn't create, because you want to make sure that you give acknowledgments there. Okay, all right. For the Explorer, I'm going to skip this right now because nobody said they hadn't finished the Explorer. If we have specific questions about the Explorer, well, let me go through it because you can go back and change some things if you didn't do it correctly. Explorer, the same thing. If you make sure that you address the prompts. First thing, make sure that you choose a computing innovation. If you don't choose a good innovation, you're going to lose a lot on your project. For it to be a computing innovation, it has to use a computer or program code as part of its functionality. I always tell my students, if you struggle to think of something, think of an app. An app, has program code. So you're going to be safe if you choose an app. For the written response, some people get purpose and function mixed up. A purpose is the goal of the innovation. Function is actually how it works. On 2C, when you're talking about the effects, you're talking about the results of the innovation being used for its intended use, not for some crazy use. We're always talking about in this write-up if the innovation is used as it has been intended to use by its maker. Okay, for 2D, data types are also mentioned. And when you talk about data types, you don't need to just talk about data. You actually need to talk about the type of data. You need to identify the type. And if you look on the scoring guidelines, we actually attach that under resources for this session. If you'll look on those, they list out several types of data: integers, numbers, booleans. Those are just some of the examples. And be careful not to mention collection devices such as sensors. You need to talk about the type of data on 2D. And for 2E, the biggest tip that I have to give that people missed is they just list their sources at the bottom of their paper, and they don't actually describe by using in-text citations where those sources are used. And the last thing I want to add on that is for the artifact. If you create a poster, a video, whatever you create as an artifact, you need to make sure that you identify the computing innovation somewhere on that. Don't assume that the person viewing it will know what your artifact is actually about. So make sure you include those. We already have a few questions. Somebody asked the question, how do we draw circles and rectangles around them? Is there a website? Okay, it depends on what tools you have. If you're working on a Chromebook, you can actually snip out, use the snipping tool, and you can snip out a section of the code, and you can use the draw tool to overlay and draw a circle. An oval. It doesn't have to be a perfect oval. It just needs to be marked. Rich, do you have any suggestions on that as well?
Yeah, also, I think some people have tools that will allow them to actually drag with their mouse and just draw squiggle lines. Even if you just take your mouse with whatever software you have and just circle it with a crude oval, that's good enough. You're just trying to help the reader identify what you thought was your algorithm code, and then just put a rectangle around what you thought your abstraction was, and that will be good enough. You don't have to get real fancy with the graphics.
Yeah. One thing on that, at the reading one year, I graded somebody's create, and they snipped out their code and they put a filled oval on top of their code. Well, you save your code as a PDF, so you can't pull apart the layers and look at it. So make sure if you use any of those shape tools that you click unfill, so the person reading it can actually see the code below.
Yeah, one reader seems to have mentioned that they put in Paint, just with the draw tool, symbols around it, and that's plenty good enough. Anything that will clearly identify what your algorithm and your abstraction are will be acceptable. So did we need to go back to the slides at all? Because
I think we're through with the slides, yeah.
Well, there was something that I, because of time, wanted to skip over and just make sure you got to your summary. But I only mentioned the traditional AP questions, and I definitely have to make sure everybody has a heads up on the third part on the AP CSA exam this year that was not on previous exams. And this is a question that's going to ask your students to actually write about programming rather than writing the program. And this is, I thought, very appropriate for after Gina talked about the create performance task, because that's exactly what we do in the create performance task. We actually have students write about the code that they wrote, and they really get their credit for writing about that code, not for the code itself. Well, in Part C of this sample exam, notice it says, and again, I highlight what I think the student should jump to right away. Get cheapest Gizmo by maker is exactly what they're supposed to be writing code about, but again, they're going to write about that process rather than writing the code. It returns a least expensive Gizmo, so it's going to return a reference to Gizmo. And it is by an individual from a given maker, which means you're going to probably, again, have to send it to maker. So make sure your students at least know this is coming, that they will have a question where they're going to have to write about what they would have to do. In particular, in blue, write a description of how you would change the Gizmo in online purchase manager classes in order to support this modification. If you remember the previous question, they didn't have anything about how expensive the Gizmo was. So now you're going to have to say, I need to make a method, public Gizmo, get cheapest Gizmo by maker, parenthesis, string maker. And if they do that, they will get credit for this first part, and then they will have to write about what instance fields did they need, what other methods would they need. And so again, they're not writing code. They would simply say, if I want to get the cheapest Gizmo, I would need to have a method get price in order to use that to compare the Gizmos. So this is a question that, again, you could read everything, but you should jump straight to what is the method associated with it, what is the return type, what is the parameter, and then thinking in the context of those classes that were already given, what are the new fields and what are the new methods needed to accomplish that task. And this type of writing is exactly what Gina was talking about for the create task, writing about your programming rather than actually writing the program code. Any other questions that we see coming up?
I think we have a couple of questions, Rich. The first one is, are we only, and they're referring to CSP, are we only sending bits of our code or all the code? Actually, you're doing both. You're sending three things. You're sending a video of your code running. and it has to be a minute or less. If you don't adhere to all their requirements, when you try to upload it to the digital portfolio, it won't take it. Then you're uploading a written response, and inside the requirements for the written response, it asks you to snip out the algorithm that you created that has 2 other algorithms, and it also asks you to snip out the abstraction that you created yourself, and you'll put that in the written response. And then you'll submit a third thing. You'll submit your entire program code. So what I ask my students to do, I ask them to snip the algorithm, and even if they do it block, they use the snipping tool and they do that parent algorithm and those 2 included algorithms, they put those near each other so they can put a big old oval around the whole thing and turn that in that section. And then they put the abstraction, the student created abstraction, in that section right after they wrote out about it. Then when they turn in their entire program code, even if it's 30 pages of text code, I still have them marked down in the code, because the goal in the reading, when teachers are grading those, hopefully if you included everything in your video and your written response, they'll never go down and look at your entire code. But if something's not clear or there's some kind of confusion, they may go down to your entire code to look at those things, and you want to have those things marked there too so they can quickly see. You know, the goal when you're doing this writing is you're going to want it to make it as easy as possible for the person grading it to see that you address the prompts. Don't try to make it tricky or try to use fluffy and different words. This is technical writing. If they have a specific thing that they request in the requirements, you make sure you give them that specific thing and it's clear that you've addressed the prompt. Okay, Rich, you have a question. Can we use BlueJ or other programs to check our work?
So that's a great question, Rhea, because I just had this conversation with my students yesterday during our session. We were actually reviewing, and students say, I really don't want to use certain word processors because they keep capitalizing my letters because I don't have the settings for writing code. I have settings for writing English paragraphs. And so it's almost a disadvantage to have a word processor that's not designed for code, because you will have to keep fighting those settings if you haven't changed them already. So I encourage them to use an editor, and the directions say you should use an editor like, and they give examples. Well, I think an editor like BlueJ or an editor like any text editor that actually allows you to highlight the reserved words, allows you to even through colorization check syntax, would be way better than using a word processor that actually kind of contradicts what you do, may start capitalizing things, may start changing the spelling. So I highly recommend students find an editor they want to use to create code where it will help or support your creation of code. Word processors traditionally will not help you write that code.
That's a good question. Thinking ahead. The next question for CSP, does word count matter for written responses? Does it need to be exactly 200 words or 150 words? That's one of those tricky questions. As a teacher in my class, I tell my students that we need to meet the requirements. And if it says 150 words or less, we need to meet those requirements. You know, you can read your paragraph and you can reword things to make sure you have plenty of words to get it all in and the allowance that they've given. Is it on the rubric? If you look at the scoring guidelines, there's not a place that counts off for word count, but you've got to think of too, the person reading your work. We grade thousands. I'm talking about like 89, 99,000 of these. Can you imagine grading that many papers and reading all that? I tell my students, if everybody ran over just 10 words, how much extra you would have to read. And I find too, sometimes when I'm reading something big, you get lost in it. So you really need to stick to the word count. For my class, for my students, I say you have to meet the requirements. And when we do practice work, if they run over, they get points counted off. But for the AP exam, if it's not on the rubric or the scoring guidelines, it will not affect your point score. But you know, there's those things like somebody getting lost in your writing that I wouldn't want to chance it. So I would be very careful to stick with the word count. What do you think on that one, Rich?
Yeah, I want to kind of further support your perspective. Gina and I have both been at the reading. We understand that when you're given instructions for the reading and you're looking at that rubric, you know that there are practical things you have to do to, as Gina said, grade thousands of these exams. So I tell my students, sometimes if you didn't follow exactly what the prompt said, you still may get credit. But why would you want to give a reader an opportunity to justify not giving you the point? So whether or not they're actually going to do that word count check is not the point. The point is do exactly what they ask you to do and no more and no less, and you are maximizing the probability that you will get full credit. Never give the reader, by you failing to adhere to the prompt requirements, the possibility of justifying not giving you the point. And that's my perspective I share with my students.
You want them to be able to quickly look at your written response, quickly identify where you've addressed the prompts, so they'll give you credit for it and move on. If you write one of these long things like I've seen before, sometimes you have to really hunt to find something to give credit to students for. And you don't want people to hunt for your answer. You want it to be completely obvious that you've addressed the prompt. And if you stick to those word counts, I think you'll have a better probability of getting credit.
You know, that's another great point, is if the prompt says you need to address algorithm, use the word algorithm in your response. If it says you need to address the concept of an abstraction, say my abstraction is. Again, emphasizing what Gina keeps sharing with us, make it as easy as possible for the reader to find your intended response and then give you that credit. Do we have any other questions at this time, Gina?
I don't see any up on the screen. While we're waiting, if you have any questions, go ahead and put them up there. Remember the exam dates for CSA. Rich, do you know the date for CSA?
We're on the 15th, which is a week from yesterday.
Week from yesterday, and I looked at the time, and the time is actually kind of different. It depends on your time zone. It's 3 p.m. Central and 4 Eastern.
And
I would go ahead and
1 o'clock at Newbury Park High School.
Right. So depending on your time zone, you need to go in there and check and make sure that you're completely aware of the exam time. For CSP, there's not going to be any online testing. It's just going to be the performance task, and you need to have those prepared and turned in before 11:59 Eastern on May 26th. I'm going to tell you like I would tell my students. Don't wait till the 26th to turn in your stuff. Turn it in early, because can you imagine all those last minute slackers that are turning in their work on that day? Actually, the first year of the CSP exam, there were so many students trying to turn it in the last few hours that there was a lot of freezing up and system problems. And a lot of students have mixed up the time zone, thinking that they could wait to turn in their work, and they missed the mark by being on the wrong time zone. It's 11:59 Eastern time zone. So you need to make sure that you keep up with that. And I would advise you to get your stuff done early and turn it in. Don't wait till that 26th to get all your work done for the performance test.
I will share what I shared with my students. I actually have different sections. One that's a year-long course. We're on block schedule alternating. And I have a section where they didn't start until late January. So we are doing every day 90 minutes, and some of those students are just filling or completing their first performance task, even though it's relatively late in the year for the other course. And I tell them, if you don't submit and you start to work on the second performance task, the create, you will have that hanging over your head. You will think, okay, maybe I want to go back to change, but it will probably negatively impact what you're doing for your create. So I tell them over and over, you're never done, but you do have a publishing deadline. And don't allow them to do the May 26th as their submission date. Say, you need to submit that much before that, even though you're not done, even though you know you could edit it and make it better. Commit to a publishing date, upload that, so you can then relieve yourself of that stress of thinking about it, so you can fully commit to focusing on the create performance task, and then spend the rest of the time doing that until, what I tell my students, no later than the 20th. You should have something you could upload by the 20th. And then if you have to, you can upload to the 23rd, 24th. But please don't wait till that last day, because the system gets overwhelmed and you are then giving yourself a lesser possibility of having things go well. So do it as soon as you can get that publishing date that you self-impose.
And when you upload it to the digital portfolio, you have to submit as final. Your teacher cannot go in and do that for you. You have to release it saying that this is your final work that you are through. If there was a technical problem, like your file, you submitted a history paper instead of your code or something like that, that is the only reason that a teacher could send work back to you. They're not even allowed to do that. I've had to run down students before that left things in draft mode and they didn't submit it as final. And here I am the last few days trying to find somebody that could get a message to them to submit their work as final if they want credit for it. It's going to be more difficult this year with people spread out and not being in schools and in classrooms. So make sure that you can get that work submitted as final as soon as possible, so there won't be any hang-ups in getting your work scored. Okay, when I looked at the poll earlier, 100% of the people that are online today have not finished something, have not finished their create. So make sure you put those questions, no matter how silly that you think they may be. Somebody else may have the same question. Put the question in the chat box so we can help you out. My best advice for you is to get it done, address the prompts, get the basic, the minimum requirements done first. Then if you have time, you can bedazzle it. I've had students that spend so much time on fire and crashing sounds and things like that that they don't meet all the requirements. Make sure that you meet the requirements first, then bedazzle it, make it look good, make it look better. Make sure you address all the prompts in your writing, and then go back and take the submission guidelines, and we have linked that in the resources for this session. And you could also just go out and Google that, AP CSP submission guidelines, and if you search on that, you'll actually get a document that looks like a rubric, and that's what they give us when we go to the reading. We use that to score your exams. I would go by row and check my work and make sure that I did. Y'all, there should be some really good scores this year. You know, with the performance task, I'm sure your teachers have done a great job in class teaching and preparing you for this. You have the rubric, so you know exactly where to get the points, and you have to address all those rows on the submission guidelines to get the points. So there's no surprises for CSP this year. We know exactly what we have to do to get the points. Okay, and also if you have any questions about Explore, I kind of breezed through that really quickly. If you have any questions about Explore and you've not submitted as final, you can go back and fix those things. So be sure and let me know if you do, so we can help you out with that.
I'm going to also go back to that original statement I made, and hopefully for the AP CSA teachers, they will have their students practice this. I see on this slide, they have the first question. They're going to get 25 minutes. And then after that 25 minutes, 5 minutes to submit, upload what they did. If they have a paragraph of text, it could be useful for them, but especially those students who are English language learners, I would recommend that if they feel like fighting through those paragraphs is really tough for them, they just jump to the code immediately and ask themselves, what is the type they're going to be working with in this particular problem? And a type is always associated with fields and methods. What we informally say in August, the stuff and the functionality of that particular type. And if a class, as you immediately glance at it, has no fields, that doesn't necessarily mean they're not needed for the class. It means that question will not require the students to use instance fields in any of their answers for this particular problem. So if that is true, we have found in the past on the development committee, when we did include instance fields, students would use them as part of their answer, even though we knew as question writers it was not something they could do. So they will purposely leave the fields out to tell you, to warn the user, you're not going to use instance fields as part of this answer. You're simply going to use the type, and you're going to call these methods get the maker, is electronic, and equals. And then I could read this next paragraph, but I would encourage your students to jump straight down to the next part of code and identify the type. And again, types are fields, methods, and constructors. If there is no constructor, if the constructor was omitted, that means this question does not allow you or does not require you to make a particular instance of an online purchase manager. So have your students focus on, what did they give you? A field? You're guaranteed going to use that field for this particular solution. They gave you 2 methods. Those are the things they're going to write. So I would have them practice this, hopefully, if they can, over the weekend or over the early part of the next week, and see if they can start abstracting out what the question means. It will help them go so much more quickly. Any other questions or comments for the good of the group, Tina?
I don't see any right now. We're going to watch chat. Please go ahead and add your questions. And we have so many, 100% said they're not through with Create. I think we should spend a little time on the Create PT, Rich, if you don't mind. And I'm going to go each section, and we'll share in case we have more tips about those sections. The very first requirement is, aside from the video and the written response, the very first section is 2A, and you are supposed to, it gives you instructions to provide a written response or an audio narration. You have to include the programming language you used, the purpose, what is your program meant to do, the purpose of your program, and what did the video you make illustrate. And this is what, with my students, it says that you can do a written response or an audio narration. I always, always, always require them to do that written response. If there was a technical issue with your file, how would someone know that there was audio there that they couldn't hear? Audio is not a requirement. And for my students that do the audio narration, most of the time they write it down anyway to read off, to record.
Gina, you
yes,
might correct me if I'm wrong, but I believe there was an update this year, and they're not allowing audio narration for their videos this time. They must write in the summary of what it does.
I'm so glad. I'm so glad, because that was a worry for me, for students to do that. I always made sure that mine wrote those things down. Y'all, that's an easy one. Everyone should get those points. You're supposed to identify the programming language. The programming language I used was AppLab. The programming language used was Snap. The programming language used was Java. Easy, one sentence. The purpose of your program. What is your program meant to do? Is it meant to educate? Is it meant to entertain? What's it meant for? What was it made for? And the last thing is you have to talk about what is that key thing that you illustrated in your video. You know, it may be a game where they score and get points and get lives and lose lives. You know, you're not going to have all of Call of Duty in a 1-minute video, but there may be a certain segment of something that you created that you want to show. Make sure that you explain what your video illustrates. It would be sad for me to know that somebody didn't get the points on that first one, because that one should be, you know, that should be one that everybody gets the points on.
And Gina, you and I have probably both seen during the actual reading, students have a video, and when you read their summary, it doesn't seem to be in any way connected to what the video illustrated. And I emphasize to my students, I understand how that can happen. You make a video, you write up a nice summary, and then you say, I'm not real happy with that video. I think I'll do this video again. And then you decide to do something a little differently that you think is maybe cooler. And suddenly you have a video that doesn't illustrate what your original summary said, and you forget to update the written summary. So warn your students, make sure you make the video, make sure you understand exactly what that video is illustrating, then go back and write that summary so it definitely matches up what the readers are going to see when they look at your work.
Yeah, that's a good tip. Okay, the next one, this for me, the last couple of years, and I think overall it was the most missed item on the written response. This is where the students have to talk about the incremental and the iterative process of building their program. When you think of something in increments, you're talking about the steps that it took to make the program. You have to do the incremental and the iterative. So you have to talk about both. So in your write-up, you should use the word incremental, and you should talk about steps. The steps it took to make the program, what you went through to actually code your program. Then the next thing you're going to be talking about is the iterative process. Part of the iterative process is when you go through and you design and then you create something, and then you get to a point that you're going to test and debug it. If you test your code and there's something wrong, or you see an opportunity to make it better, what do? You go back and you redesign, then you recode and you test again. Do you see, like if the process was a circle, that shows iterative. Iterative is means to iterate, to go back. I could go back and retest it and find another bug. Guess what I would have to do? I would have to go back and recode. So I'm spending a lot of time iterating through those steps to create my code. So make sure that you not only talk about the steps that were involved in creating your code, the incremental process, but you talk about the iterative development. You have to talk about two distinct points where you had a problem or an opportunity. So think of if you had a problem with something in debugging and you had to go back and recode and fix it, or if you get to the testing and debugging, you have someone have a peer test it for you, they make a suggestion, or maybe you see something better and you go back. That's another example of the iterative process. You have to talk about two distinct points where you either had a problem or an opportunity, and you have to explain what you did to fix those or incorporate that in your code.
Well summarized, Gina. And I'll just add, when students are having difficulty, it's really good to point out to the students what they typically would put in if it was wrong. And in writing that you in your program included a loop in your program, and therefore I was iteratively developing, is the most common mistake I've seen in that particular portion of the submissions. So emphasize to your students that writing a loop in your program is not what they mean here in terms of iterative development, and that's probably the most common wrong answer that we see every year. Again, Gina summarized it so well. Make sure you plan, write the code, run the code, test, and debug. If you do those steps, every time you now plan, that's your opportunity to improve. Every time you're debugging, that's your opportunity to fix a problem that occurred. And if you emphasize to the students to focus on those concepts, they will avoid those errors that we see usually from people misinterpreting what those words mean.
Okay, and I'm so glad Rich talked about that, because it brought something else to mind. Y'all, we're in a weird situation right now. We're all in the same weird world right now. And someone asked the question on the teacher community. They had a student email and say, "Can I have my mom test my code for me?" Guess what the answer is? No. No, you're only allowed to collaborate with your peers. So after you do your code, you can email a classmate, send them the link and say, try this out, see what you think, see if there's any problems. Can you get your brother? No, peer. It has to be a classmate. Y'all, the thing is, this is collaborative for you as a peer in your class to test out. You can't have your teacher test it out. You can't have your mom. You can't have your dad. After the exam date and you turn it in, you get a score, that's fine. But right now, you have to write about, in this prompt, you have to write about those problems and opportunities. And usually students write, I had my classmate test this and they found an error and they suggested this. How do we know as readers when we're grading it that your mom is not some software designer? How do we know that your brother doesn't work for Google? We don't know those things. So we have to flag those things that suggest that you've violated the rules of the exam. The only people you're allowed to collaborate with are peers or your classmates.
And
so
this is where we should probably really emphasize, Gina, we should really emphasize that we have to make this split between APCSP and APCSA, because there is absolutely no collaboration in APCSA while you're doing this exam. And Gina is, and again, you've said this, but I know there are people that can easily be confused by this, is this is only for computer science principals. During the create performance task, are you allowed to collaborate on the writing of your code? But again, I would emphasize to my students, the responses you're writing about the development of your code have to almost always be about the independently developed code. So even if you're collaborating on code and you want it to run, the things you wrote about should be the independently developed code, not the collaboratively developed code, with the exception of the one portion where you're writing about your problems or your opportunities, your difficulties, your opportunities. One of those can be a collaborative experience, but everything else, even if you collaboratively develop the code, you must have independently developed code that you're writing about in those responses. And again, APCSA, no collaboration with anyone. You simply write that code during the exam and you upload it to the College Board.
Right. And y'all be very careful. In my classroom, in Miss McCarley's world, I tell my students, it's so difficult. You know how it is to be in class and there'll be a strong, dominant person that wants to do all the coding. You can't do that on this. I encourage my students to all have their own projects. They do their own coding and they have a peer test it for them, just to have another set of eyes. And that's what they talk about. Sometimes it's too hard to divide out, well, did I do this? Did you do that? Did we really do it together? And it's like Rich says, when you're reading the prompts for the CSP exam, it even overstresses. It says you individually created. So it'll say that you independently created, you individually, and they'll repeat themselves through the instructions to make sure you understand that it's supposed to be you, that you did alone. CSA is all you. You can't be getting any kind of help on that. You do it yourself, your own exam. Be very careful on those. But that row that we just talked about, where they talk about the independent, they talk about the incremental and iterative. That's the row that most people lose points for, is they don't address both those things. They just address one in the written response, so they don't get the full point. So be real careful on that. Be sure, as we're talking, if you have questions, we still have time for questions. Be sure to add those. The next two rows that are in the create are 2C, where you actually create an algorithm that is integral to your code, that is used throughout your code, and that contains two other algorithms. Contains two children algorithms. Some people call it a parent-child relationship. That has to be an algorithm that you create. Some have to have math or logic. When you read it, sometimes it's hard to get lost in it. I just tell my students, make sure they all have math or logic. To me, you have to work not to have math or logic. And that takes away the doubt. 2D talks about an abstraction that you develop, and it says individually on your own. Is individually not on your own? I think they're kind of redundant there, but they're wanting to stress the point that you have to create it on your own. You can't collaborate with anyone else. It can't be built in the code. So some people that use AppLab, they'll mark with a rectangle these event handlers. A lot of the event handlers in AppLab are generated by the code itself. You can only mark the part that you create. If you build a function, you jump over to JavaScript and you build a function, that's what you can mark for that. But be very careful only to mark abstractions that you create. Okay, I think we have a few questions, Rich.
Yeah, Gene, I just saw a question, and I did type in a response to the chat, but I'll try to utilize that as well. The question was, what would be the best way to study for the CSA free response questions? Oftentimes the questions are hard to read, which take away time to write the actual code. I particularly have English language learners who are very bright, capable programmers, but it takes them so much time to fight through the English text that I emphasize to them, but I also think it benefits for all students to don't go to this first slide, which is the text associated with the question, first. I tell them that perspective of when you're on a development committee and you're writing questions, you write the code, you determine what that code's going to do, and oftentimes the names of the methods, the parameter list, and the return type tells you exactly what that code is going to do. So why do you write all that text? Because as a development committee member, you have to anticipate all the possible questions you think any student may have. And so then they write the text to fill in those gaps. But if I look at that code and immediately jump to the name of the class, the functionality associated with that type, and realize there are no instance variables and there are no constructors, I know that's a type that I'm going to be using for this particular problem. And I just need to remember a gizmo is something that can get its maker, check to see if it is electronic, and check to see if it's equal to another gizmo. They need to be able to look at that and understand by glancing at the code that that's the abstraction they need to go to the next step. Now when I move here, again, I could start reading that, but if I jump straight to that code and say, not only do I know what this class is, an online purchase manager, which keeps track of online purchases. Why? Because that's the name of the class and it should tell you what it is. Purchases is a variable and it's an instance field that I know I'm going to be using. Otherwise, they wouldn't have included the instance field in the problem. And I know that instance field is an array list of Gizmo references. And then finally, when I see part A and part B, that's what your students should immediately start thinking about in terms of how could I write that particular method. And when it says count electronics by maker, that tells me I'm going to write code to count up how many of the electronics are there based on a certain maker. And I ask myself, how am I going to figure out what the maker is? The string maker is the parameter that's going to tell the writer of this class what they're supposed to use to determine which maker it is. So I'm going to check to see if this maker matches up with the maker that is associated with each object that I'm going to refer to in that array list. Same here, has adjacent equal pairs. Adjacent may not be a word that students are comfortable with, and that's where they start reading this. Returns true if any pair of adjacent purchase Gizmo false. Still not quite sure. So finally, after just looking at the code and hopefully not having to read a lot of text, if they look at these tables that the College Board usually provides, and it says, is electronic, true, false, false, they can look at the particular examples given the particular list of gizmos, and they can check to see whether or not their understanding of maker and electronics and all of the variables associated with that method really match up what they thought. They can see the input and see the output produced. They can also come down here and look at count electronics by maker and see the actual counts. So especially for those English language learners, get them used to abstracting the types and the methods, and if associated with fields, making sure they understand the fields. In some cases, they have to read the constructors. If they do that, then when they read the text, I think it will make much more sense. And oftentimes, they don't even have to read the text because the code itself is descriptive enough to where they can finish.
Okay, Rich, can they use code runners like Eclipse, etc. on the CSA text?
So I read the instructions to mean you have to use an editor. So in terms of running the code, oftentimes, if you'll notice, they don't give you a complete class. They don't give you fields. They don't give you constructors. So actually, to get the code to run, you would have to add way more than the problem asks for. So it is definitely not recommended that you try to run code while you're doing this AP exam. But it is very strongly recommended to use an editor that will allow you to, as you enter the code, indicate whether that code is syntactically correct. Word processors actually contradict syntactically correct code because it will start capitalizing things. It will sometimes auto-correct spelling, even though in code the correct spelling was there, it will change it to what it thought the English should be. So I strongly recommend using an editor that is associated for the development of code. But please don't encourage your students to try to run it because there will be big gaps in what you would actually need to get that code to run.
Okay, we've got a couple more that we need to get to quickly. I think we're getting close to time, but someone asked if they're allowed to use code on the Create PT that they found online. All the code that you turn in for your independent work must be created by you. You can use code from libraries or other sources, but you have to comment the code and give credit to the code. Even if you work with a peer, a classmate, anything in your code that you did not personally create, you need to give credit. But you can't turn it in on any of those responses as code that you created. That can't be your abstraction. That can't be your algorithm. Another question is, does the children algorithm have to be from the same parent algorithm? And the answer is yes. You have to identify or select an algorithm, and that algorithm has to contain within the big identified algorithm 2 other algorithms. So yes, that has to be associated together. Do you have anything more, Rich? I think we're very close on time. We're 3 minutes over.
I don't see any other questions that we haven't addressed, but if someone does have a question they think they addressed, just put something in the chat real quick and I'll scan again.
Mm-hmm.
Yeah, I think we've addressed the issue of code runners. I think we have addressed the issue of use of libraries, the algorithm discussion. So hopefully we've addressed all the questions. And I want to thank Gina for doing what she's done. This has been very helpful for me and my students, and I appreciate all of you generating questions because as I tell my students, every time you ask a question, it helps so many other people learn well.
Right. Okay. So remember, read the requirements, address the prompts, do your own work. Give credit if it's not yours on a certain portion of the create only. Everything else has to be independent. Okay.
Well, Gina, thank you again very much for doing this. And
Okay.
I was very happy that you asked me also to help participate in this. So it's been very enjoyable, always working with teachers and the students that are all trying to improve their computer science understanding.
Okay, good luck. Remember those deadlines.
See ya.